Dear friends, in this question, we have a tube which is filled up with a liquid whose density is given rho, area of the tube is given A, and length is given L. Okay, so let's suppose it is filled up with a liquid rho, something like this. Okay, and it is given cross section A. You can assume this point as a 1 and this point as a 2. Question is what key when this tube is accelerating with an acceleration of what will be the pressure difference between 1 and 2, and as well as calculate at which point pressure is more. Is P2 is more than P1 or P1 is more than P2? Okay, we'll see. So the answer will come in terms of acceleration, length and density of that fluid. Acha. What I'm going to do, okay, this is your 1D body I'm taking, take 1D. Now if you make the ABD of this full fluid, otherwise just to feel you can just assume like a what pseudo force. Tell me what is the direction of pseudo force on this fluid when it is moving in forward direction. So when we are entering in the frame of tube, you will be getting that there is pseudo force acting on the fluid in the backward direction. So just because of pseudo force action, one thing is very clear: the pressure due to the fluid on the tube is more on P2 than P1. Why? Because of pseudo force. Okay, otherwise one more thing we can say, if you make the ABD of this fluid, okay, I'm just making the ABD of this fluid, and you will be observing he said there is a pressure acting from this side, and this is what you can say. So this force is nothing else P2 into area. Acha, what is the force acting from this side? We can say the force acting from this side is P1A1. You can also make the point ABD, and you will observe on the point ABD of this body, sir, we are getting one force in this direction P2A, one more force we are getting in this direction which is nothing else P1A, and that is your mass of this fluid, and this fluid is having the acceleration of in forward direction. So if you apply Newton's second law for this moving fluid, means accelerating fluid, so we can see, sir, F net is equal to what? Mass of the fluid into acceleration. Okay, so what is the net force on this fluid? We can say it is acting in the forward direction. Why? Because we have taken the acceleration in the what? Forward direction. So net force would be acting in the forward direction. So from here we can say, sir, P2A minus P1A is nothing else mass into acceleration. Okay, so if you see, we can take common from here what? Area term we can take common, where A is nothing else area of this tube. Okay, I think you're getting it, the cross section area I'm talking about. Mass of this fluid can be written as what, beta? Rho into volume. And what is the volume of this? Say it's a cylindrical in nature, so directly we can say the volume of this part is nothing else area of the base into length, which is given in the question. So we can say volume is nothing else, beta, A into L, and this is the acceleration. Okay, after solving this we are getting P2 minus P1, and if you see both the side area is coming, so it will get over, and we are getting an expression rho AL. Please remember this expression, that is very important for us to solve the bigger questions. Okay, and also from this expression we are getting, acha, do remember one thing first. So what is the pressure difference we are getting? Density of the fluid, acceleration into L. This expression is something like that, rho GH. Rho GH is what? In vertical column, and you know that in vertical column when we are coming down, the pressure increases by rho GH, and when we are going down, pressure decreases by rho GH value. Okay, in the same way, that is a density, that is a unit of acceleration, that is the length. Just remember one more thing I would like to say for this kind of question. In the opposite direction of acceleration, if you see in the opposite direction of acceleration, sir, pressure increases. So as we are going from point 1 to 2, the pressure increases by how much value? Rho AL. L is the length of that much fluid, length how much you're taking it. how much you are considering. So please remember this formula, that is actually very effective. So that is your pressure difference. Okay, in the opposite direction of acceleration. Acha, how do I remember? I'll tell you. You can remember like that, sir. In the opposite direction of acceleration, pressure increases by how much value? Rho al. Just keep in your brain. Or in the same direction of acceleration, please remember pressure decreases by how much value? Rho al. Okay, one question I'm going to solve. See it. The question is what? Okay, let's suppose, sir, we have a container. I'm just taking a cuboid or cube container. You can take anything. Right now I'm taking this container. Okay, which is accelerating with an acceleration of a. We have given 2 points. Let's suppose point number, I'm taking point number 1 and point number 2. Okay, and just keep some name, point A, point B. One more point I'm taking. Let's suppose this is a point. You can take anything, point A, point B. Let's suppose one more point we have, point C and point D. This length is given, you can assume. So this length is given what? Capital N. And this length beta what given? You can take it what? Capital H. Okay. Wait. Okay. I have to rub this. So this length is given what? Capital L. Achha, one more thing. So this height is given, you can assume. It is given in the question. This height I'm assuming. So this is given Y. And this is given what? This is given from A to C given. So this is given X. Question it is asking, what is the pressure difference? What is the pressure difference between point A and B? Okay. Okay. If this acceleration is not there, we know that sir, at the same level pressure would be same inside the fluid. Achha, that is fully filled with fluid. Okay. This is fully filled with some fluid of density. It is given rho. It is given. Okay. Now, if we calculate the pressure difference between point A and B, so we have two options. Either we can come down, and after coming down, we can move in the left direction to reach at point B. Okay. Otherwise, we can also do one thing. First, go in the left direction, something like in this direction, that, and then come down. It's up to you. You can choose any one of the path. So I'm going to walk from A to B. First, I'm going down. Then I'm going with where? First I'm going down. How? First I'm going down like this, and then I'm coming here. Okay. So let's suppose this is some point. You can assume O. So when we are just doing walking, then you will observe first we are coming down here, then we are going here. Okay, like this. Okay. So when we are coming, let's suppose pressure at point is what? PA. So when we are coming down, pressure increases by rho gh value. Okay. So PA plus rho g, total height given H. Very good. Now we are just going from O to B. So when you are going from O to B, so we are going in the opposite direction of acceleration. And as we have studied earlier, key in the opposite direction of acceleration, pressure increases by how much value? Rho A into L, because we are just moving how much length? L length. And finally we have got what? PB. So from here we can calculate which pressure is more? PB. So we can say the pressure difference between point B and A is nothing else rho GH plus rho AL. Whatever the values of A is given, we can keep it here and we'll get the answer. Same question, if I ask you what is the pressure difference between point A and D, the same logic we can use. Achha. It's not mandatory that you have to walk from A to B like that only. You can also do walk from here to here. You'll be getting the same thing. Okay, not required, leave it. Achha, if I want to calculate pressure difference between A and C, you can do walking. It's up to you again, I'm telling. You can do walking first down, then left like this. Okay, you can do like this. So first I'm coming down, then what you will write? So pressure at point P, point A is what? PA. Now I'm coming down. Beta, how much value I'm coming down? If you can see, this value is what? Equal to Y. So we can say PA plus rho GY, because in down the liquid pressure increases by rho GH value. How much you are going down? Again, if you see, we have reached at this point. So when we are reaching at this point, again we have to come in which direction? Backward direction, something like that, which is again the opposite direction of acceleration. So we can say again the pressure will increase by rho a x amount. If you see, that is nothing else given, rho x, that is nothing else, that is equal to what? P at D. So this is how we can also calculate the pressure difference between point A and D, which will come rho ax plus rho gy. So that is your answer for this question. So we can solve many good questions by using this concept, and I hope you're getting my point. Thanks for watching this video. If you have many more doubts regarding fluid, you can ask me. Thanks for watching.